Hope all of you are able to see my screen.
Yes, sir.
Okay, thank you. So the next important one which we are going to talk about is distribution systems. So we are discussing about several components of the entire distribution network. So starting from uh, intake structures from where actually we collected. Then we talked about pipes. We talked about you know farms. So these are the different components which actually forms the entire distribution network. Now, apart from that, based on the nature, the way the distribution networks is spreaded, which is called a distribution system. So, based on their nature, how they are actually expanded or stretched to reach to the furthest consumption point, we can have different type of distribution systems, and we'll be discussing them in detail. Now, before going into that, let us try to understand that what is the requirement of the distribution system. So now the chain is quite clear to all of you. Water is taken out from the source and then it is sent to the treatment plant. Now, once the water is properly treated and made a safe and wholesome water, it has to be supplied to the consumers in their individual homes. So here comes the role of the distribution system or proper planned distribution system. So the water has therefore to be taken from the treatment plant to the roads and streets in the city and finally to the individual houses. Now, this function of carrying water from the treatment plant to the individual homes is actually accomplished by well-planned distribution system. And this distribution system, if you see, it consists of several components. The primary and predominant one is the pipelines, which we have discussed, different type of pipes, its material, which one is most suited in which type of condition. And the several type of pipes we have, main pipe mains, then we have branch pipelines. So, and all these different type of pipes are associated with some sort of appurtenances which help in keeping them intact during the service life, right? So we need several type of, as you can see here in this particular slide, like in distribution system we have pumps, reservoirs, pipe fitting, instruments for measurement of pressure, flow leak detector. So all these appurtenances holistically create a distribution system, and cost of distribution system is about 40 to 70% of the total cost of the entire scheme. So this is also very important to remember. So if you can make a very planned distribution system, so that would significantly influence the cost of the project. Now, efficiency of the system depends upon proper planning, execution, and maintenance. So these are the three aspects, and depending upon the type of the city, age of the city, the nature of agglomeration, the type of people living there, in terms of their economic status, we can have different type of distribution system. Now, as far as requirement is concerned, so it requires for a good distribution system should have the following aspects, which I'm going to talk about. So it should be able to carry the treated water up to the consumer's point with the same degree of purity. This part we discussed before. Fine. Next is uh, it should be economical and easy to maintain and operate for longer period of time. Pipes should be designed in such a way that it can be utilized for the fire fighting situations. Like it should be capable of supplying the requisite amount of water for firefighting during such needs. Apart from that, it should be capable of supplying water at all the intended places within the city with a reasonably sufficient pressure head. So this is a primary problem if you see in most of the and government operated water supply scheme. Mostly in the older cities you will see that this maintaining head has been a big problem. So this is a big aspect and most important, one of the most important aspects to consider. Fine. Next is this. This should be safe against any future pollution or contamination. So if there is a chance of contamination in the ground or in the groundwater, there should not be any effect in the water which is being conveyed through the distribution network. It should be safe as not to cause the failure of the pipelines by bursting it, etc. So that is another one aspect. It should be fairly watertight, and we need to minimize the chance of loss, and should be able to supply the maximum. Should be able to supply such a quantity of water so that the maximum hourly demand is satisfied. So mostly these are the different you know requirements which are very very important and are associated with the distribution systems. So now we will, as I mentioned before, like there are predominantly four different type of you know pipe networks. So we'll be discussing them one by one. So we have dead end or tree system. So if you see dead end or tree system, so dead-ended tree system, this from the schematic diagram you should be able to understand, like the dead-end system is also known as tree system. So in this case there will be one main pipeline, and that is known as main pipe. Which is denoted as M and in bold. So this is the main pipeline. Let me show you through the laser pointer. So this is the main pipeline. So this is denoted as capital M. Now, from which you will have several different submain pipes which will be connected at different points in numbers. So this is one, this is another one, this is another one, this is another one. So these are basically submains. So these are submains which is denoted as S, and each submain then divides into several branch pipes and called the laterals. So branch pipe has been actually designated as capital B. You can see here. So they are also known as you know laterals. So from the laterals, service connections are given to the consumers, and so from the plan which has been given over here in the left bottom left hand side, if you see them, you should be able to understand that this system is suitable for irregular developed towns or cities. Fine. So that the layout may have to be adapted for older towns which have developed in a haphazard manner without properly planned roads. Fine. So in this system, the water flows in one direction only into submains and branches, and the diameter of the pipe decreases at every tree branch because once it starts from there, the need of water discharge or the rate of discharge is very high. Once you go towards different tree branch, what happens is the requirement of quantity of water which needs to be conveyed is reduced, and therefore the diameter keeps on reducing once it goes, and it's a one way. So we have the dead end. So towards the dead end the diameter should be minimum. Fine. So there are a few advantages associated with such kind of systems. So the first one is the distribution network can be solved easily, and it is possible to easily and accurately calculate the discharges and the pressures at different points in the system. So this is easy because this is one way and you have dead end in one point, and that is why things are easier to calculate. Now, lesser number of cut-off valves are required in this system. Cut-off valves, basically the sluice valves, which we say, because things are one way, and the more you are going towards the farthest corner, the diameter is also reducing, and the number of consumers are also reducing. Fine. The shorter pipe lengths are needed, and the laying of pipe is easier in this case, and the diameters of the pipes used are smaller, and hence the system is cheap and economical. So we have flexibility to provide lesser diameter towards the laterals or the subments, and based on the total number of consumers, we can basically adjust the diameter of the pipe, which is in other cases may not be possible. That is one of the advantages of this particular method. Next is it is cheap, simple, and it can be extended or expanded easily. So you see, in one point it is dead end, so if it is easily expandable if you want, or if the situation comes where you need to expand that particular water supply system, it can be done easily. So the laying of water pipes is simple, and it can be extended at any point in time. Now we'll be talking about the disadvantages. None of the system are not having any disadvantages is not possible. So any system you talk about, this will have some inherent advantages as well as disadvantages. So now we'll be talking about the disadvantages. So in this method, what happens is water can reach a particular point only through one route. So if there is a damage or any repair in the pipeline is required, then you need to stop completely the water supply scheme for the entire city. Fine. So thus, if damage occurs or repair is taking place in a main pipe or in a sub-main pipe, considerable areas would be affected. So this is the most important point. Next is, there are numerous dead ends in the system which prevent the free circulation of water. So this stagnation sometimes cause degradation in the quality, as well as this stagnation can change the quality into of the water into in negatively. So this will deteriorate the quality of the water, and that is why it should be changed in those dead ends. Often the water should be changed, or it should be thrown out. Fine. Next is, now in this system, the discharge is reaching a point from only one direction. The supplies during firefighting cannot be increased by diverting any other supplies from any other side. See, to reach to a particular consumption point, you have only one entry, right? And there is no other way you can reach to that particular consumption point. So if a huge amount of water is required in a shorter period of time, there is no other way by which we can provide that extra amount of water, since we have one way system, and that is the main one of the main disadvantages of dead end or tree system. Hope you have understood the entire advantages and disadvantages which I have talked about. Things are pretty logical, so you should be able to remember, for what kind of cities you should take which type of distribution system or not. Next is grid iron system. So grid iron systems, if you see here, things are much more organized and disciplined. From the schematic diagram, we can decipher that. So in this case, what happens is, this is also known as interlaced system or reticulation system. So grid iron system. Now, what happens is, in this case, the main submains and the branches are all interconnected with each other. So for any well-planned city or town where the roads are developed in a grid iron pattern, let's say if we talk about Jamshedpur, you might have seen, if you go to the Bishnupur, and you will see that even if you don't go, you can check it in the Google map, like, in few of the places where it is planned. So all these roads are, in grid iron pattern, and you can basically follow the same pattern to lay these pipelines, and in this system is therefore more suitable for the well-planned town and cities. And we have several examples. Chandigarh, Jamshedpur is the oldest planned cities we have. And apart from that, mostly these days, whatever cities are being developed, they are all planned cities. And in those cases, for any young cities where you have planned roads and all those roads and connecting points are laid in grid iron system, this particular distribution system would be most apt. Fine. Now, apart from that, if you say at any point in the line, the pressure is balanced from two directions because of the interconnected network of pipes. So this is one way very advantageous, and in another way, it is not that much good. So we'll be discussing those scenarios in the advantages and disadvantages. So this particular grid iron system has several advantages. The first one is, since in case of repairs, very small area will be devoid of complete supply, as because you have connection from both the ends. So it is easier for you, or it is easier for the operator to close a certain point. Suppose you have a problem over here, so you can basically uh, keep this particular portion out of service, and you can maintain, still you can maintain the water for the entire other cities, which was not possible in case of the grid iron or tree system. So that's the most important benefit we can say. Next is every point receives supplies from two directions. So because of that interconnections, or different interconnections, the dead ends are completely eliminated, and therefore water remains in continuous circulation, and hence the chances of pollution or contamination because of stagnation is eradicated in this case. Fine. Now, next is, since the water reaches at different places through more than one route, the discharge to be carried by each pipe, the friction loss on the side of the pipe therefore get reduced. Fine. And number 4 is the firefighting aspect. Now, more water can be diverted towards the affected point from various directions by closing the, or adjusting the other valves in the other part through cut-off valves or sluice valves, and by this we can provide more amount of water or more quantity of water in a certain consumption point for a particular period of time. Now, as far as disadvantages are concerned associated with the grid iron system, so this system requires more length of pipelines and a larger number of sluice valves. So the initial cost of construction is increased. Next is it, so basically once you are consuming more number of valves and the length of pipeline is more, then the construction cost is also be increased, and the maintenance cost will also significantly be increased. Fine. Next, the design is difficult and costlier. The calculation for determining accurately the size of the pipes and the pressure at the various key points is really a tedious job and may require the services of design experts and even computers, since uh, each point is connected from two different directions. So there comes the complicacy, and that is the reason it is not that easy. So we need to have sophisticated softwares, or we need to have professional designers to help in this aspect to finally calculate. So the overall design is little bit tedious and complicated compared to the previous one. So now we'll be talking about the ring system or circular system. So from the name itself, you should be able to get a view of how this system would look like. So in this case, our main pipe is actually surrounding all the branches and submains, and that has been actually depicted in the figure which is given in this particular slide. So this system is also called a circular system, and in this system a closed ring, either circular or rectangular depending upon the different aspects we can choose. So this closed ring is actually acting as the main pipes, and is formed around the area where to be served. And the distribution area is divided into a rectangular or circular blocks, and the main water pipes are laid on the periphery of these blocks. So that is what, through the perimeter we are putting the main pipes, and in between the submains are placed, and as well as the branch or the laterals are placed, within the zone which is actually surrounded by the main pipelines. Fine. So the ring system is very suitable for town and cities having well planned roads. So often for well planned cities we can have ring systems, and this system is also used as a looped feeder placed, like where we have high demand area, or where the water demand is high for a certain period of time. So these kind of systems can be used as looped feeder. So sometimes we can feed more amount of water in these areas. So along with grid iron system, this can be installed additionally to submit the demand on those particular areas which I have talked about. Now, if we say the advantage are actually similar with the advantage of the grid iron system, there is not much difference. So you can actually go through the same, or you can mention whatever we have discussed in the grid iron systems. The same kind of advantages as well as disadvantages are here also, and they are quite similar. Structurally there is a difference, means in planar view. However, the philosophy of these two systems, like which we discussed previously, gridiron and ring systems, are quite same, and that is the reason the merits and demerits are also same. Now coming to the last one, so that is basically the radial system. So in this system, you can see that we have the distribution reservoirs, which has been denoted as black circle, and then we have that main pipeline, and in this case what happens is, if a city or a town is having a system of radial roads emerging from different centers, the pipelines can be best laid in the radial form or radial method by placing the distribution reservoirs at these centers. So what happens is, so we can have in radial direction, since our roads are also radial and the nature of agglomeration is also like that. So this system would be apt for those kind of situations. So water is pumped to the distribution reservoirs, and from the reservoirs it flows by gravity to the tree system of pipes. And the pressure calculations are easy in these systems, and layout of roads needs to be radial to eliminate loss of heads in bends. So usually we don't provide bends, and we try to avoid providing bends, and in those kind of area where you have this radial type road networking, there only this kind of radial system is very suitable. So now we'll be talking about an important aspect, so that is system of distribution. So if we say system of distribution, so basically method of distribution in this case, that should be mentioned. So the main objective of a distribution system is to develop adequate water pressure at various points of the consumer's taps or consumer's point. Now this part I mentioned before also, that this maintaining pressure is the biggest headache for the engineers and for the strategists and for the uh, administrative people who are actually implementing or giving this facility to the people. Now, depending upon the level of source of water and that of the city, topography of that area, and other local conditions and consideration, the water may be forced into the distribution system in different ways. So the first one is the gravitational system. So we have actually shown here the gravitational system. Now in gravitational system, what happens is, when ground is sufficiently high above the city area is available, and this can be best utilized for distribution systems in maintaining pressures in the water mains. So you need that high, sufficiently high ground. And in this case, if you see the figure, you will be able to understand now the city level is lesser than the source of the water, and which is very very ideal situation to be considered in case of gravity distribution system. So our clear water reservoir is also located, so we need not to, in this case, we need not to construct overhead tanks, so which we'll be discussing later on, to get that additional pressure. uh, we just simply, in the ground level, we just simply constructed the freshwater reservoir tank. And from there, since we are getting the pressure head is also drawn over here, and then you have the buildings, and can see that in this case the pressure will be maintained easily. Fine. So suitable when the source of supply such as lake, river or impounding reservoirs is at sufficiently higher density, as no pumping is required. Therefore, it is most reliable systems for the distribution of water, and water flows in the mains due to gravitational force. So this is the most important aspect, since there is no pump or no other machineries are involved in creating pressure in the distribution system. So this system is quite reliable. In whatever happens, you can be rest assured that you will get the uninterrupted water supply with the constant pressure in the consumption point because of the topographical advantage. Fine. Next comes the pumping system. So this is the more conventional systems which we might have seen in most of the cases. So in the pumping system, the treated water is directly pumped into the distribution mains without storing it anywhere, because storing is not going to help in this case. And for this reason, this system is also sometimes called as pumping without storage system. So constant pressure can be maintained in the system by directly pumping, and so the pressure is basically provided because of the pumping. Now rate of flow cannot be varied easily according to the demand unless number of pumps are operated in addition to the standard ones. So this is the most rigidity aspect of this pumping system. In this case, the flow, or the flow is cannot be regulated, since you are applying pressure through the pump, and which is quite constant. So if the demand is less, still you need to provide, or you need to maintain the same rate of flow. Supply can be affected during power failure or breakdown of pump, since the entire distribution depends on the pump. So if there is a problem associated with the pump, let's say, for example, loss of power, or there is a breakdown, or there is a problem, or you need to maintain the pump. So in those cases, it is really difficult. So sometimes we have the standby pumps which can solve this problem to some extent. So that is the reason, diesel pumps are also, in addition to the electrical pumps are installed to utilize them as standby. And during fires, the water can be pumped in the required quantity by the standby units as also. So that is another one flexibility associated with the pumping system. Now we'll be discussing about the most effective one. So that is the combined pumping and gravity system. Now in combined pumping and gravity system, what happens is, this is also known as dual system. So in this case, the treated water is pumped at a constant rate and stored into an elevated distribution reservoir, or we can say that overhead tank, from where it is distributed to the consumers by the mere action of gravity. And sometimes the entire water is first of all pumped into the distribution reservoir, and then many a times it is pumped into the distribution mains and reservoirs simultaneously. So there are many possibilities. You can see here in this particular figure schematic diagram. So you, after taking out the water, treating them, you can simply put it in the overhead tank, and then you can maintain the head, and by the help of gravity you can. So this is again combination of pumping and gravity. On the other hand, what you can do is simultaneously you can send it to the overhead tank or service reservoirs, and at the same time we can send it to the distribution main. So simultaneously you are sending water in both the units. So when the pump is switched off, then if there is a demand, water can be taken from the service reservoir. Fine. And you have enough flexibility in this case. So if the demand is increased, you can actually switch on the pump and you can actually satisfy the extra demand or additional demand during that period of time. The flow in the distribution system comes from both pumping station as well as the elevated reservoirs. So that's the most advantageous part. As in this system, water comes from two sources, one from reservoir, another one from second one from station. It is called as dual system or combined system, and this system is more reliable and economical because it requires uniform rate of pumping but meets low as well as the maximum demand. So the flexibility associated with this particular system is the most among these three. The water stored in the elevated reservoir meets the requirements of the demand during breakdown of the pumps and for the firefighting as well. So during firefighting, we have several options by which we can meet the demand. So these are the different advantage of the combined system. So now I will be talking about the laying of pumps. So there are some total provisions which needs to be followed, as far as. Now before going into this, let me mention two things, which I mentioned in the beginning also. Now, based on the running nature of the water in the distribution system, it can be divided in two parts. So if I one is continuous system, another one is intermittent system. Just I have not mentioned here, however, for your knowledge you can hear this and you can remember. The continuous system is the best system and water is supplied for 24 hours. Now, this system is possible when there is adequate quantity of water for supply, and in this system, sample of water is always available for the firefighting or due to continuous circulation. Water always remains fresh, and in this system, the lesser diameter pipe are required. So, rusting of pipes will be less, maintenance cost will be less, and as well as in this case, losses will be more if there is a leakage in the system since water is being distributed throughout the day for the entire 24 hours. However, intermittent system actually is in this case where water is not in plenty, so then the water is divided, supplied in different zones in different time, and in each zone there will be some fixed hours in a day or alternative days where water will be supplied. Now, in this case, water actually comes in a particular consumption point after a certain interval, and that is why it is actually called as intermittent system. Fine. So this system has some problem. Intermittent system is not preferred. So in this case, because of alternating wetting and drying, so the cost of maintenance increases, the chance of rusting increases, and if since the water, during non-flow periods, the stagnation and because of leak, the chance of pollution is increased, and more wastage of water can happen since the people would have the tendency to store water more than what they need. And again, what will happen is next time when water comes again in the consumption point or in the tap, they will simply throw the water and they will again collect the fresh water. So in terms of collecting water, they are actually wasting some amount of water. So wastage is more in this case. So this is another two type, I just wanted to mention continuous system and intermittent system. And this is based on the nature by which water is supplied in the distribution system. So anyway, I'll not start, combined. I'll not start the laying of pipes because it will take some time. You should try to understand till now whatever we have discussed, and I'll continue in the next class. If you have any questions, any doubts, you are welcome to ask me.